My name is Trevor Pugh. I'm the CEO of Deep Imaging Technologies. Welcome to a presentation of data collected in the Anadarko Basin in March of this year. There's 24 hours worth of data being presented in this video. We've got it down to somewhere in the region of 10 minutes, and we'll be showing highlights of the project as it went. In order to orientate you, the stage number is marked each time we put a new stage up. The vertical pipe in the center is the lateral. The toe is at the top, which is in the northern direction. Heel is in the south. These numbers here mark the distance from the well for each of our sensor points, which are these colored dots. As the frac continues, you'll see this gray image, which is our sensor field, moving down towards the heel. Stage 2 will now run. Notice immediately that we have pumping already occurring with flow. Looking at this chart at the bottom of the screen, we're zooming in here and you can see almost immediately that this pressure goes up. We get a response in the westerly direction, and then as we get a pressure drop right here, which is an indication of a frac over, and you saw a large increase in the easterly direction. Overall, we have estimated that the frac propped 125 feet in the westerly direction and 320 feet in the easterly direction. This was a successful frac. We would call this a bilateral frac. It went in both directions, and there was a good volume pumped for this frac. When this zooms back out, we'll put an ellipse around that area so we've got a base marker for what's going on. Another interesting point here is that the strength of the signal from our receivers over the frequency range is an indication of vertical height. We think there's a significant vertical height in this data. So we're going to jump forward in time here. You can see we did 7 stages very quickly. We're now on stage 8. We want to show you some pretty significant data from stage 8 through stage 12. The series of stages that you're about to see will demonstrate how we can directly affect the client's operation by giving them information about how successful a frac was, which direction it went in, and more importantly in this case, how it could affect future operations in terms of production and enhanced oil recovery. We've zoomed in on stage 8, and stage 8 is interesting in the sense that it shows that we have a longitudinal frac occurring. You saw that very early in the operation we had something that went a little bit to the east, but it doesn't stay there. That signal is moving back and forth, which indicates to us there's no proppant, but we get quite a strong response that goes to the south and along the lateral. This is actually an important component in our operation here because it indicates that the stress profile has changed direction. Now we're going to start stage 9. When we zoom in, you'll notice that there is a small signal that's appearing around about the 600 foot mark in the westerly direction, a little ways into the fracking operation, and as time goes on, you can see that now, that westerly move, and then as time goes on you will see that there is a dramatic easterly response that is a long way out at 1,000 feet, and it builds back towards the perf location, and it's very south of what happened earlier with in stage 8 with the longitudinal frac. This whole setup is very interesting to us because we think it indicates a low perm streak heading in the easterly direction, where there wasn't much effort required to push the fluid into this location. And this is borne out by what happens on stage 10 also, which we'll see here shortly. As you can see from this, we've gone about 1,000 feet plus to the east and about 600 feet to the west. We're zooming into stage 10 here, and you'll see immediately we get a very strong signal out at quite a distance from the perf location. This is very much indicative of a high perm streak. The effect here is that the frac is probably not doing what they want. They're not probably increasing the surface area. As you can see, the fluid tries to go out further into the westerly direction, but retracts, so they're not pushing any proppant any further out. all in all, we suspect that when they actually come to produce this area, they get really high production initially and it will fall off very rapidly. Now we're going to be zooming in on stage 11, and this stage actually operated appropriately, and you'll see as we start running here, once I've zoomed in, that we get some additional responses. We're getting a response in the area of stage 9 and 10 that is going positive. This to us indicates potentially that fluid is moving out of that location. And if you look at the pressure curve on below, you'll see that it appears the pressure is actually increasing when they turn the pump rate down. This could be indicative of fluid and sand coming back into the borehole through the new frac perf location. Additionally, you can also see right after a biovert drop occurs, they get a screen out. We think that possibly the fluid and the sand coming back into the system may have made that situation worse. A screen out is when sand gets into the perfs and prevents, blocks things up and prevents fluid being pushed into the system. The total extent of this frac is 625 feet to the east and about 125 feet to the west. As we move towards stage 12, it's important to understand here that each frac affects the next frac in the chain in different ways. So zooming in on stage 12 here shortly, you'll see that this is predominantly a westerly direction frac. We don't have full data unfortunately here, but the important factor, there's two important factors in this. One is that they again screen out towards the end of the operation, and two, that after they screen out we get a very little change in our signal for the remainder of the operation. This is sort of a background validation for our system. You can see the frac building here fairly well, and shortly we're going to come to a screen out event. As you can see now, the pressure goes up very high. This can be caused also by the biovert system that they're using. Biovert is a product they're trying to use to prevent heel end fracking. This is where the frac goes towards the heel end of the well. We actually think that, looking at our data, that most of the fracs did tend towards the heel, no matter what they did. There are a few exceptions, but basically that was our conclusion. The data we've presented here could be interpreted at several levels for the client, and each level would produce an improved ROI for the client. The first level would be at real-time data. That would be when we're actually running the operation in the field. And the data you're looking at right now for stage 12 would tell us, after the screen out, that they needed to move on to the next stage. The reason is because stages 9, 10 and 11 show quite clearly that there's a hydraulic area, an area that has been hydraulically loaded, and it would be unlikely that you would make additional surface area for improved production. So we could tell them to move on. That would be a time savings for them. Secondly, in this area, we could say that stage 2 worked very effectively. However, between stages 2 and 7, the westerly push was incomplete, leaving this area unfracked. And that perhaps they should consider well spacing to be slightly different, like reducing it instead of 2,000 feet down to maybe 1,800. This again would improve the amount of oil that they could return from their operation, and hence improve their ROI. The last piece that you could get from this real-time data would be the lateral frac that occurred in, or longitudinal frac that occurred in stage 8. This is actually an indication to the operator that his modeling that showed how the stress profile should work probably didn't recognize that that stress profile was being altered as the frac progressed down the well. There's a really classic example here of a longitudinal stress profile change turned into a perpendicular one, as is shown between stages 8 and 9. At the next level, this would be longer term planning related to, say for example, enhanced oil recovery, EOR. In this case, we would tell the client that if they did an injection plan that they should avoid injecting fluid into the area around stages 9 and 10. The reason is because this is a high porosity region, and it's quite likely that any fluid injected in there would find a very easy channel into the adjacent lateral. This would result in reduced production at the other ports on the lateral they're injecting from. The detection of a possible high perm streak through the formation to the east in stages 9 and 10 is a good indication of the difference between more traditional methods of microseismic, which are looking at acoustic events, and an EM technique such as DIT uses. Our technique measures resistivity changes which are directly attributable to the fluid movement in the rock. This is not possible with seismic systems. In summary, DIT has created a platform system that could be used to monitor the oilfield operations in various stages. That would be fracking, flowback, EOR. In addition, we're able to do operations in other industries, and basically the system can measure any resistivity or impedance change that occurs subsurface in a relatively short time period. I really appreciate you listening to this presentation, and if you have any questions, as always, please get in touch with me at trevorpugh@deepimaging.com. Thank you.